Before moving on with the interface method, one more point that has to be cleared here is that you have a start method being called, and when you have a start method being called, and obviously the start method is going to look into a run function that will be existing in either of these classes. So if a run function doesn't exist, particular thread won't be executed. I'll display it with the running of the program. So this is the program shown earlier where you had this run method in high, which had a sleep function for 1000 millisecond, and here you had another sleep function for 500. So definitely when you execute this program, you're going to get an output as follows, like hi, hello, hello, hi, hello, hello, etc. This was explained in the previous topic. Now what I'm doing here is I'm going to change these methods over here. So I'm defining it as row and I'm defining it as row. Now if I rename both the functions and I try to execute them, basically it leads to an error whereby we are not getting an output in this particular compiler. So we have to assume that it is an error just because of the fact that the start has not observed a run method in any of the classes from which it is supposed to run. Suppose if I make this run and I try to execute this particular program, what would be my output? It would be high, 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 high for 5 times being displayed. Like I said, this method high will be displayed. High will be displayed. That means the start is able to fetch the run function from this class, but it has not been able to find the start run method from this particular class. Again, I make this view and I make this run and I try running it again, execute it. Now the output would be hello, hello for 5 times. I hope that point is clear. So when an object of this thread is created, it would be definitely looking for a start method, which would be calling a run method in the actual class. Now we are going to look into a case where this we are implementing a runnable interface. So we are going to do it in two variants. One is this variant where we are going to use an interface object, and other is where we are going to use a class object. So that will be shown to you as program and we'll understand what is the output. Now basically this is an interface that is being created over here. Now we have learned about what is the difference between a thread class being extended and an interface being implemented. So as you can see over here, since this is an interface called runnable, it will be having the statement hi implements runnable. Again, this logic is same, the run function, your sleep method being called, your hello, which is again implementing a runnable, and you have this run function over here. Again, this all concepts same. Now we are going to see two variants of implementing this runnable interface. Now you have this high object being created over here. Now this objects are being created in the form of obj1 and obj2 over here, and obj1 is calling start and obj2 is calling start in this particular two lines of. We have another set of code over here, and this will be explained in the compiler section. Now in this particular concept that we are going to learn right now, we have already understood that this is an interface, and interface is nowhere similar to that of a thread class. Now if you remember, a thread class object will be having a 5 stages like what we had discussed over there, the new and the dead and all the status that's coming in between, and then it was able to access methods like start, run, sleep, block, and so many other kind of things. So an interface concept cannot run the aspects or the traits of a thread. So we, in this line of code, what we have over here is we are creating two objects of obj1 and obj2, and obviously let us activate these two lines of code, and we can see that obj1 and obj2 are calling the start method. But what we see over here is that there is no start method that is associated with an interface object. I repeat, when we had a thread object, it had a start method, it had a run, it had a sleep and all. But when we come to this particular obj1, that object is being created over here, it is not inheriting from the thread class. It is implementing a runnable interface. So basically it cannot have a start function. So when we actually run this program, we can see that it is not able to find the start function, and there is no start function as such divided in this code also. If you look at the code, there is only this function called run. So let us try replacing start with run. So when we replace this start with run and this start with run, and when we try executing it, we can see that the program works fine. Hi, which is displayed 5 times, and hello, which is displayed 5 times, exactly the way we expected this program to run, and it is able to manage all these things. Only thing, we haven't come to this section of try, where we are having a thread function being called, but again, I think it is because of this lack of error that we are not getting any issue. um, so again, it comes under a try catch, so that wouldn't be of much importance over here. But any possible situations, any clarifications, if I can provide, I'll do it. But let us now move back to this particular statement over here. This is what I called as the second phase of implementation of a runnable interface. Now, what I've done here is I've showed you the difference between calling a start function and a run function. So a runnable interface doesn't have a start method. It has only a run method. So maybe another one point that I can call over here is, I think I will try replacing this code with another letter U, E, and have that object obj1 only calling creating a function run. And it cannot override any abstract method called run. Error is displayed over here. So it is and let's try calling this particular, or replacing this also with the new function name rue, rue. It has created an error, and it basically sees that it cannot override an abstract method called run, which is existing in runnable. So it is evidently clear that an interface should have a method called run. So this particular point that I mentioned is very important. So a interface can support only this method called run, which should be in the class, and it will not accept any other name for its function. So that was the concept that I mentioned over here. So this was using an concept of the interface itself. Now what if we want to use this function called start itself? So what if we want this to behave like a thread, or to exhibit the traits of a thread? Then what we do is, we have created these objects of the interface class, and we are going to convert it into thread objects. So if you look over here, you have a statement over here which is calling the thread class, and you're creating an object T. And this obj1, that is an object created over here, is passed as an argument of this thread function. So basically this object which related to interface is now converted into the traits of a thread. So you have T1 as well as T2, which is now created over here as like threads, and we have these functions being, or these objects T1 and T2, calling the start function, just like a thread object which we saw in the previous program, like obj1 and obj2 over there. This T1 and T2 now belong to the class thread, and when we execute this particular program, you can see that you get the same output. So when it comes to running an interface, we actually discussed of two things. One, about objects of the interface itself, where it cannot run a start method, it can only run a run method, which is what I showed in the video done previously, and then you can convert it into a thread object and use the start method to execute this particular program. So I hope these two things are clear. Now, why do we use this thread class and runnable interfaces? Based on the fact that Java, if you remember the PPT that was shown before, I had said that the Java program, it supports single, multi-level, and hierarchical inheritance. We avoided the concept of multiple inheritance in Java, which was why we brought up the concept of inheritance. Now, sorry, no, not inheritance, sorry, interface. So when we talk about this significant difference between the thread class and the runnable interface is that if you look at this three inheritance schemes like single, multi-level, and hierarchical, that is basically single inheritance in different forms. If you look at the diagram, let me take the diagram and show it to you. If you look over here, in single inheritance also, it is a single inheritance applied over here. In multi-level inheritance also, evidently if you look over here, there is a single inheritance and another single inheritance over here. And hierarchical inheritance also deals with a single inheritance statement. So if you look over here, there is now a statement like class C extends class B and class A. There is no statement as such. So effectively we can say that in Java, single inheritance is the most predominant one, and there cannot be any statement which can be like class C extends A comma B. That is not accepted in Java. So the basic problem with your using a thread class or extending a thread class method is that there is no other possibility of extending to another class or for getting any extra inheritance benefits. While in the second approach, we can implement interfaces which can be more than one in number. We have already seen two different programs in the previous videos where we had two interfaces being called into a single class, or in two interfaces that can be called into another interface. We had looked into such programs in the previous videos, and basically that is the difference why you have the runnable interface approach is more preferred than the thread class method. So I hope that point is clear. So with this particular video, the topics of Java is over, and we hope we can make a better understanding of the topics by doing frequent revision, and please do put in effort to learn this particular module. I wish you all the best. Thank you.